Swayam Prabha. Digital India. Educated India.
Welcome back. Welcome to the course Geology and Soil Mechanics. So, today we are going to start the new topic, that is soil compaction. Now, what do you mean by compaction? So, in your day to day life you have come across this process, this compaction process, but knowingly or unknowingly, I mean, what are the mechanisms and how it is done, you don't, I mean, you never thought about that. So, however, in case of soil compaction, that means when the compaction process is involved in the soil mechanics, we need to know few things, and we need to know and where actually the soil compaction is required and how to obtain or how to achieve the soil compaction in the field. Now, in the construction of highway, you might have seen in several occasions that in the construction of highway, embankments, earth dams and many other engineering structures, loose soils must be compacted to increase their unit weight. So, you might have seen that whenever you are passing somewhere, so in the highway construction or the embankment construction or the earth dam construction, you might have seen that rollers are passing over the layers of soil, right. So, you might have seen that, and you know from the knowledge or from your intuition that the roller is compacting the soil. Now, this passing of roller or the layers of soil or how much moisture, I mean water will be mixed with the soil. So, those things are having some I mean specified quantity, right. So, you cannot have some arbitrary number of passage of roller or arbitrary amount of water to be mixed with soil. So, this cannot be arbitrary. So, everything is decided based on some mechanics or based on some parameters, right. We will now learn those things in this particular topic. Now, coming to the general principles, compaction in general is the densification of soil by removal of air, which requires mechanical energy. So, if you recall or if you remember that if you want to put food grain in a particular jar, and when the jar is not sufficient enough to accommodate the whole food grain, what you generally do? You just shake the jar, so that the food grain again you can I mean the more amount of food grain can be accumulated in the jar, right. You do that. So, that is nothing but your compaction. So, basically what you do during your shaking, when you are shaking, you are giving some mechanical energy, right, I mean through the shaking, and because of that your air inside the food grain is going out, and because of that you are getting the reorientation of the particles, and ultimately you are getting the densification, so that you can accumulate more food grain in the jar. The same mechanism or the same methodology or same phenomena is equally applicable to the soil mechanics. So, in soil basically what we are doing, we are densifying the soil by removing the air from the soil matrix through some mechanical energy application. When water is added to the soil during compaction, so during compaction we generally add water, as you have seen in the highway construction when the rollers were passing over the soil layers, at the time some person used to put some water in the I mean in the compacted soil. So, that means we are mixing water. So, when water is added to the soil during compaction, it acts as a softening agent on the soil particles. The soil particles slip over each other and move into a densely packed position, right. So, what basically you do, you add, you try, I mean continue adding water inside the soil, and the soil and the water will basically act as the lubricant, right. So, when the water will go inside the soil matrix, the soil particles will reorient and they will be coming much closer to each other and they will be packed densely. So, this is basically happening due to the slippage of soil particles due to the lubrication of water. Now, you keep on continuing the addition of water. Now, what will happen? So, you are adding some water, you are getting some densification, you are adding more water, you are getting densification and so on, but at certain point that means at beyond a certain moisture content, any increase in the moisture content tends to reduce the dry unit weight. That means if you continue adding water inside the soil, initially or the gradually you will be getting some increase in the densification, which is measured by the dry unit weight, as you have seen in the very first few lectures, that dry unit weight is nothing but the indication of the densification of the soil packing, right. So, if you keep on increasing the water content, that means water addition in the soil matrix, then initially you will be getting the increase in the dry unit weight, which is indicating the increment in the densification. But after reaching a certain point and beyond that point, if you still adding the water inside the soil, what will happen? You will be getting some reduction in the densification, reduction in the dry unit weight. That means your densification is now getting reduced. So, this phenomena occurs because the water takes up the spaces that would have been occupied by the solid particles. Now, if you add more and more water, so water will take the space or take the position of the soil particles, where the soil particles were supposed to be there, but now water is taking that space. So, you will be getting some reduction in the densification. That means the soil particles will be dispersed and ultimately you will be getting the reduction in the dry unit weight. The water content at which the maximum dry unit weight is attained is generally referred to as optimum moisture content, as OMC. Now, what does it mean? So, what you are doing basically, you are adding water and you are measuring dry unit weight, and slowly if you keep on increasing the water content, then you will be seeing your dry unit weight is also increasing. But at certain point you will be getting the maximum dry unit weight for a certain moisture content or the water content, right. After that it will fall, because the water will occupy the space where the particles are supposed to be, right, already we have seen. So, you will be getting initial increase, it is reaching some peak and then it will be falling down. That peak will be denoted as the maximum dry unit weight. You will be getting the maximum dry unit weight at the peak, and the corresponding water content or the moisture content will be known as optimum moisture content or the optimum water content, which will be known as OMC in soil mechanics. So, now onward, whenever I will be talking about OMC, that means that will refer optimum moisture content. Now, to quantify or to get the results. So, I mean if you want to establish this kind of curve, say dry unit weight versus water content, then you need to perform some laboratory experiments, and that is known as standard Proctor test. So, basically what we have here, so we have a mold, steel mold, okay, which is having the volume of 944 cubic centimeter, okay, 944 centimeter cube. So, this is the volume of the mold, and the diameter of the mold is 101.6 millimeter. Now, what we do basically, we add some water, okay, some known quantity of water in the soil, taken soil, and then we mix it properly, and then we put that thing in the mold layer wise. So, in 3 layers, so number of layers will be 3. So, say we are putting the first layer, and with this hammer, so this is the hammer, okay. So, with this hammer we tamp it or we ram it for 25 number of blows. So, 25 number of blows will be coming from this hammer, and each layer will be compacted by 25 number of blows of this particular or the specific hammer. So, hammer weight is 2.5 kg, and the height of fall of the hammer which is free fall, that is 30.5 centimeter, okay. So, now this is the first layer we have compacted, now we are putting the second layer, and then we are compacting again, then we are putting the third layer, we are compacting again, and then